Hello, welcome to week 11 of the Programming for an Engineer class. We now are to the point of switching to Python. Uh, I hope you all did well with the midterm in C++. And so now we go from the language that is a little bit low level and focus more on performance. That is good to use, but with moderation, to a higher level language, Python, that is actually designed for high productivity of the programmer. So, an overview of what we are looking at in this class. So we're looking at how to install Python very briefly. We will continue to use Visual Studio, so that's not really any significant change. We start looking at the Python syntax at a basic level and some data types and some operation in Python. Generally, it's just starting to be familiar. Once you know languages like C, C++, moving on to Python is extremely easy. The syntax is very similar at the high level, very few important differences. And but then also the interpreted environment makes it so easy to also try things out and so on. So Python nowadays is kind of the most popular scripting language. In fact, I would say it's become really the most popular language, especially in data science. And the idea of scripting language is really that is a language that is interpreted, not compiled. And so it's really much easier to use the environment. It can be used basically just as a calculator for simple tests all the way to full-blown computing capability. And one aspect that is more really powerful is that can include easily lots of libraries. So anything that really require performance, you can go back and create a library in C++. So many libraries available from linear algebra, machine learning, web frameworks. If we have time, we'll actually look at an example where I do some web scraping and creating some statistics and plots on, for example, on the recent COVID cases. And also it's nice to be able to do some of those things easily yourself instead of being stuck with whatever plots you might find on a newspaper. And then, as I said, C++ can be used within Python in moderation. So anytime you find a piece of code that is really important in terms of performance, that could be written in a small C library and then linked from Python. So this is a very simple comparison of two pieces of code that are effectively, functionally, I would say, identical. One is in C++ and one is in Python. And so here, after I've done some C++, you have a typical thing of including IO stream to enable the IO functionality. Then you build a simple function to print the hello world. And then to start your program, you define the function with name main. So again, C has this standard of defining where the code will start. And then here we read a number in input, and then we print hello world, the number of times that of the input number. So very simple. There is a loop, reading something input, calling a function, and so on. So this is the equivalent of the function in Python, for example. So here, the void hello world, blah, blah, blah. So here Python doesn't force you to declare what the function will return. Basically, if there is a return statement that will return whatever, and the interpreter will deal with the types, something that C++ would force you to do explicitly. This is the print statement, and this is the equivalent. Now, on one side, you see kind of the key of the syntax is kind of similar, but a little bit different. One aspect to notice that in Python, so here you have the def part, so this define the function, and then the indentation really describe where the body of the function is, while in C++ you have the open and close braces, so the indentation is really, it's only for visual aspect for humans, but not for the code to be correct. Again, early on, many people criticized Python because they thought that this could be a weakness when you move the file, different machines, sometimes the formatting may go away. It turns out actually is a real strength because without a lot of enforcing, practically the code is more readable and it never really is a problem. So here, then we have the reading the variable. So this is the equivalent of the cin function. This is input, and then convert the result into an integer. And then the for loop, again, similar thing. You have the describe the for, and so here is the variable case. Range is created the sequence 0, 1, 2, 3, 4. So instead of explaining step by step how to compute the indices, the variable case, it goes through a list of value in, and this is here a list, and this is just a utility function that creates a sequence of number from 0 to case count. And then the indentation again tells you what part of the code is inside the loop, so the equivalent of open and close braces. And then we just print the result. In this case, this is the formatting to do exactly the same. And then you call the hello world function. So this is kind of the, now you see how the code here is kind of more compact. It tends to be more legible even for someone that is kind of a novice. I mean, this function, for example, is super simple. Here you would have to know all kind of things, the column, because of the standard namespace, the smaller, a lot of things. So here in principle, you have to know also print and so on. Is much more intuitive. And so we can look at running code from Visual Studio. So here we have a project. Now this is a Python project. And so here you see that you define the function, and this is the main part of the code. So here in this project, I have 3 files. So since the Python does not start from the main function, you have to tell the project from which file you have to start. So if I go here and do set, let me see, sorry. So set as a startup file, this has become bold. And now the execution will start from that file. If I select this file, I make it into set the startup file, the execution will go there. So this is convenient, so I'm putting the 3 file for this particular class. So in this case, then I can do run the code. Now, since there is the input, so I can say type 10, and then 1, 2, 3, from 0 to 9, so 10 times, you call the function, and so on. So the output was also showing there. I'll go through this again later, but just to give a sense, I can put also a breaking point similar to C++. And so when I start, I can move forward. And so here I'm getting the request for the value. And so I can go and print case 0, hello world. Then it again jumps into the function, print again. So here you can see case 0, hello world, case 1, hello world again. And then I can just continue and let it go to the end. And this is also displayed here. Just this to give a sense of how easy to run things and so on, and how intuitive writing the code. Maybe actually let me make some modifications. For example, here I was using the simplified version of the print statement case and so on. So this is the one that I had. By the way, the pound symbol starts comments inside the Python code. And so here I would just run, continue, do type F3, hello world, and so on. And so here is printed in a better format. But for example, let's say that now I move hello world to the beginning here. So the indentation is gone. Let me remove and so if I run and I say 3, so I do case 0, 1, 2, and then just print at the end. You see now this print statement is not inside the loop anymore. But if I do again, tab again, goes the indentation. So you see the meaning of the code. If I do 3 now, it's alternating case 0, hello world, case 1, and so on. So it's important that the indentation, it's the intuitive way and works very well. And also Visual Studio lets you merge and expand the area, so it will tell you what's part of the code that way. And so you can see that the code gets reformatted. Oops. Anyway, so this gives a first initial sense of how to use Python in Visual Studio. Now, just to be more precise, we use Python version 3.6. 2.7 has been a version that's been popular for a long time. Lots of people still use 2.7. Now it's becoming, what they say, deprecated. So you really don't want to start by learning 3.6. The syntax is not very different. Actually, the print statement is one of the example where the syntax is different. One reason why 2.7 was so popular, there was lots and lots of library that have been ported very well in 2.7, and there are still some that are only in 2.7, and they are kind of slowly get ported to 3.6, but it's going to take a while. That's kind of the downside of having had a release that was so popular. We will use 3.6, and it's not going to make a huge difference, but there is no point in using something obsolete. And then we'll do this inside Visual Studio, so you don't have to use a new development environment. So that will make it very easy. So when you create a project, you will have something like this. You just seen in my window as an example. And if you go to the main installation page of Visual Studio, by default, you must have installed the C++ part. You can go and look for the Python environment, select the version of Python. You see that there's still 2.7 available if you really want to. Again, it's not recommended. So let's go for 64-bit 3.6 and so on. And that's just the way to go. If you have any problem during office, kind of virtual office hour, please ask for help, but this should be really a simple process by now. When you create a project, and then you go to the new project, and then Python, and then create a Python application. It's very simple. I'll try to remember at the end of the session, I'll actually create a new project. I just don't want to lose the one that is already open for the example. And then you just create an application with some empty Python file, and then you can populate that and create your project. And this is the component that you're seeing now. So you have this area, I mean, depending on layout, it could be on one side or the other, but this is the project, this is the file, and here this is the project, and here I have 3 files for 3 simple example for this presentation. And you can add the new files and so populate with more element and so on. So let's look at a simple use case. So here one can create a project with a very simple example, some computation of variables, then have a variable that has a string, another numerical variable, and then add the string with another string. So here we see the simplicity of using Python compared to C++. Dealing with string in C++ is kind of a really annoying because it become arrays and you have to put them together and so on, while on string Python just define a regular algebra with additions and so on. So let's look at this inside Visual Studio. So this is the same code example that we have seen already in the slides. And so just in a simple addition between 2 variables, an assignment of y to a string, addition another variable, and then here we have an if statement, again indentation that define the part of the code executed under a success of the if test, and then increment the x variable. Y gets added to another string, so it's kind of string operation, and then printing. So let me execute now step by step. So here, now you can see type 12, I see the previous program, I was still actually running with this highlighted. So if I want to start this code, I have to make it as a startup file, it become bold, and let's try it again. So at this point, and now we're at the beginning here, we step over, variable x is created, so again, allows you to debug pretty easily, value 11, 34 minus 23 minus 23, then variable y, hello, that's a string, z has a new value. Now we do the test succeeds, and now we're inside the if statement block of code, and so x will be incremented by 1, and x is equal to x plus 1, so that was go from 11 to 12, and then y is y plus world. So here you see the string operation, just make the addition is the concatenation of the string. Then we have a print statement that print the value, and so here you see printed hello world, here print hello world, and then the thread ends. So very simple execution. Again, when you have multiple files, remember to choose which one is going to be the file that you start the execution with. So we see how to create a simple example, run it, and then put it in a simple piece of code. Now the code, Source code is in a text file, and the extension is .py. That's kind of the standard for Python. As I said before, there are no braces. So, I mean, there are braces in C++, not in Python. And so when you have the code divided into blocks, so this is the inner part, and then there's even inner more piece of code. So you can do nesting of the code. This could be like a for loop. This could be an if statement, and this could happen only when the inside the for and only when the if, for example, succeed. So it's very simple. Once you get used to it, you realize actually it's very convenient and makes the code more legible. So here, another example, just to go through. And so here you see kind of the outer layer of the code. Now here there is an if statement. So all the code here is executed when the x is equal to y. By the way, note how it's equal, not equal. Equal would be, would be the assignment, and this is the comparison. Then you can do print. There is another if statement, and then there is further nested code. Again, this one is executed when this succeed and this one succeed, this test. And then you can do elif, so you can do else and then apply another test and then else and so on. So very simple. I'm insisting on this just because it's kind of the main distinction between the two languages, and many people overlook this or forget this and then get stuck easily for small problems. So there are basic operators for mathematical calculations, and so those are the typical plus, minus, asterisk for multiplication, and slash for division. There is also a double slash. There is a strict integer division. The modulus and the double asterisk is the exponent. So if you want to calculate an exponential. So simple examples. So for you can have a variable. So again, you don't need to declare the type of a variable. You just assign it to something. And then Python automatically trying to use the kind of simplest type possible. So if I do z equal 5 divided by 2, 5 divided by 2 is 2.5. So z has to be a floating point number. Notice that in Python there is no distinction between floats and doubles. So always try to use the highest number of so the highest precision, basically. And so you can assign directly a floating point number. And again, the idea is that because Python is focused on simplicity, not efficiency, the set of number types that are allowed is somewhat more limited because you don't want to spend too much time focused on that. For example, also in strings, you can do a single quote, a double quote, and it's basically the same. And then we saw before, you can do operation on those. So back to an example. Now we go to the other module here. So let me set this as a startup type module. Here you go. So this will start here. And so here I create a simple function that takes a variable x and it prints the variable, prints the type. Notice that I don't specify the type of the variable nor if and what type gets returned. That's all implicit. And so, for example, in C++, if I wanted to have this function for integers and for floats, I would have to write two functions or use templates. But again, that's even more complicated. While in Python, the type is created on the fly. So if I now execute this piece of code, let me maybe start from the beginning. So at the end, initially, it will create the function and then start running this. So let's keep going. And so I step over, then print. Now here I'm printing the type of number 2. And so it prints an integer. Print again another integer. Now we assign the variable z as 5/2 as in the code, and now we print again. And so here we print the value 2.5 and then the type. And so the division return a float. And so that's the value return. If I use the double slash as a division operator, that forces the result to be an integer. And so when I go in the function, that prints the value and then give an integer. So let me highlight here. You see the first time result was 2.5 and the type printed was a float. The second time the value is 2 and the resulting type is an integer. So we can keep going, and then so let me actually just do continue. So we get to the end, and so here we see that for x equal 3.456, again, because of the decimal, this is automatically a type, a float. And then I can assign s to a string with a single quote. And again, it prints the string and print the type of a string. Similarly, I use the double quote, same result, and use of a string. So those are very simple example, again, just to get things started. Notice that I started to talk about comments are whenever you put a pound symbol, from that moment on the line, it's a comment, so it's not an actual part of the code that gets executed. There is some additional, what we call documentation string. Those are really important when you start writing code and that other people want to use. It's kind of a simple way to create documentation without having a system that is too complicated, right? So here, if I have a function and then I use this triple quote, well, 3 times the double quote character, and then I close it the same way, immediately after the definition, this is considered the documentation of the function. So let me show you what that means in practice. So here, for example, let me take this away. I created this little string of documentation for this function. So this helps, for example, Visual Studio, when I hover over print val type, it actually brings forward the string of documentation that I wrote up. And so even if I don't see that part of the code, I can go in and see the explanation of what it does. And so this helps a lot in having the code in any interactive environment associated with your interpreter. You can kind of understand quickly what you're dealing with, even if it's a code that you didn't write. So we just saw stepping through breakpoints and walking through the program. Let me just show it again. If you double click on this vertical bar, this sets a breaking point. And so we can start the program from there. The function has been defined. Here you see the variables, and here on the bottom right, you see let me highlight things. So in this area, you will see later the variable here, the actual output that come from the program. And so now I can take the step over symbol. Also, it seems to be associated with the F10, but that might depend. And so here I can see the type class int, so the printing the type of the number 2 and 5. Here we create a variable and then print it and so on. So as I step forward into the different parts of the code, I can execute and I remain in control. Let's say I want to go inside the function. I can do then, instead of step over, I can do step into. You see I go into the function there. So I have the variable x, and so the variable x, in this case that was passed, has value ABC, and then it gets printed. Then I step over and then print the string, and then it backs out. So now the variable outside is actually capital X. And so this is a very nice, simple way. I get to the end, I see the console with all the print statements. So this is a very simple way to look at the code and basically have opportunity to debug and make sure that I am in control of what's going on.